School of Advanced Studies. I would like to welcome you all to the Career in Water Talk Series 4. I'm Shirley, Assistant Professor in the Department of Regional Water Studies. I'm a water resources engineer by profession. My colleagues, Dr. Renjana and Dr. Fausia, have also joined this session. Our department offers 2 master's programs, MSc in Water Science and Governance and MTech in Water Resources Engineering and Management. For more details on the programs, you may visit our website. So today, the topic of our webinar is career opportunities in hydraulics and hydrology. So let me brief about our speaker. Javas is a hydraulic modeler with Mott McDonald, Bangalore, specializing in the modeling of river systems and urban drainage systems. He is a civil engineer with MTech in Water Resources Engineering from National Institute of Technology, Canada. With about 5 years of industry experience, Javas has worked on several projects across UK, Australia, New Zealand, and Hong Kong on different types of projects, including dam breach analysis, river flood modeling, and urban drainage modeling. In addition to his role as hydraulic modeler, Javas takes keen interest in digital solutions and is a strong advocate for using new technologies and automation process in hydraulic modeling. He has excellent knowledge in GIS, especially ArcMap, QGIS, and MapInfo Pro. He has built more than a dozen automation tools in GIS and data processing using Python and VBA. I was fortunate enough to be his colleague at Mott McDonald when he joined in July 2017. We both have worked in the same team, and I always cherish the light moments, mutual support, and the group learning environment within our team of flood models. So let me proudly welcome my good pal and former colleague, Javas, for his talk on career opportunities in hydraulics and hydrology. Javas, we welcome you to start your presentation.
Okay. Thank you, Shirley, for the introduction. First off, I hope my voice is clear and I'll start sharing the screen. Please let me know if you can see the screen.
Yes, your screen is visible.
Okay. All right. So first off, thank you, Terry, for inviting me to the session. Thank you, Shirley, for inviting me. The topic I am discussing today is career opportunities in water with specifically in hydraulics and hydrology. The agenda for the today's session is I'll be giving an introduction of myself. Then I'll be talking about the required skills that one needs to develop to begin and enhance a career in hydraulics and hydrology. So there are some essential skills as well as some desirable skills which I'll be talking in detail about. Then we'll discuss different career pathways. So the different career avenues that you can explore as a professional in hydraulics and hydrology. I'll also be discussing about different emerging trends so that you can be familiar with what is going on in the industry and you can orient yourself towards acquiring those specific skills so that you are ready for the industry, you are actually future proofing your career. I'll also discuss about the chartership opportunities that are available. There are a few chartership institutes which I'll be talking in detail about their membership and chartership. I have also included some of the useful resources, some mostly websites where you can learn the skills which I am going to discuss in this presentation, and there are a few other resources which you can use to keep yourself updated regarding the current trends and regarding the current developments in water industry. So to begin, Shirley has already given an introduction. So my name is Javas. I am a civil engineer at core. I have done my master's in water resources engineering. So after that, I started working as a hydraulic modeler with Mott McDonald, which I have been working which I've been working for the past 5 years. Now, I have worked on different profiles or different type of projects within hydraulic modeling, including river modeling, wastewater network modeling, dam breach analysis, storm drainage design, uh, stormwater network modeling, etc., across different geographies, including UK, Australia, Hong Kong, New Zealand, etc. Now, let's begin the presentation about by talking about the required skills. Now, uh, I have listed a few skills that are really essential for someone to begin a career in hydraulics or hydrology. Among that, first one is GIS. Now, I have placed it as the first point, and rightly so, because of the importance that GIS has. Uh, Regardless of the different fields that you are going to be working in, or your different, regardless of the projects that you are going to be involved in, GIS is going to be a key component to all of that, be it wastewater network modeling, be it water supply network modeling, or be it a river modeling, flood risk assessment, or environmental impact assessment, etc. In all these areas, you will be dealing with GIS data in an extensive manner. So if we consider hydraulic modeling, all the input data, be it the DTM, be it the rainfall data, be it any other asset data, all of this are represented in some or the other GIS format. It might be shape files, it might be tab files, but it would essentially be a GIS file. And also the modeling outputs or the design outputs would also be in one or the other GIS format. So having the knowledge about GIS is really essential. Now I understand that for all, uh, if I'm right, almost all of the master's programs across different institutes, they have GIS as one of the courses. So it is a given that any person who has completed his master's has a good knowledge of GIS. Now, regarding the different GIS softwares, there is QGIS, ArcGIS, or MapInfo. Now, MapInfo might not be familiar for many people because it is used in the industry, but it is not very widely available. But ArcGIS and QGIS are widely available. QGIS is also a free software, so it would be sufficient that you develop skills in one of these packages. Second essential skill is open channel hydraulics. Now, if you're going to be working on river modeling or surface water drainage modeling projects, then open channel hydraulics is really important. The third one is pipe flow hydraulics, which would be helpful if you are working on projects related to wastewater network modeling or water supply network modeling. It would really be helpful if you are familiar with pipe networks as well, which would be really helpful while working on projects that involve um, design and modeling of water supply networks. The fifth essential skill I would like to speak about is hydrology. Now, hydrology is something we must have learned in our master's courses. So uh, it is really important to be familiar with the different rainfall estimation method, rainfall routing methods, etc. Now, one thing to keep in mind is that hydraulics remains the same. So wherever you go across the globe, hydraulics remains the same. It doesn't change. Whereas hydrology is specific to different geography. So uh, each specific country would have their own set of guidelines. For example, Australia follows ARR, UK follows REFH2 or FH13. There are different specifications. There is regional flood estimation report by Central Water Commission for India. So hydrology is specific to the geography. So uh, it would not be possible to learn all these specifications, but it would be ideal if we have the fundamental understanding of hydrology so that you can learn different specifications or understand different specification as in when you are working on different projects. Now, apart from those essential skills, in fact, those essential skills are almost always part of the master's curriculum. So it is a given that any candidate who have completed their masters in water resources or similar specializations would have the knowledge of all those essential skills. Now, what makes you stand out from the crowd is the desirable skills that I'm going to speak about, out of which the first one is data manipulation and visualization. Now, as we are working on different projects, we would be receiving uh, a significant amount of data, most of which would fall under two different categories. It would either be time series data, for example, monitoring from a flow monitor location in a particular river, or the rainfall data for a period of time. The second category of data is spatial data. So spatial data would be taken care of by GIS. So one would be doing all the processing or the manipulation and visualization of spatial data using any of the GIS tools. But for time series data, it is essential to have a good grasp of any of the tools. The most widely used tool is Microsoft Excel. So it is really, really important to understand, just not to be familiar with Microsoft Excel, but to be to have a sort of in-depth knowledge regarding visualization tools, regarding the different graphs, charts, etc., and also different tools that you can use to clean the data or manipulate the data. For example, when you get a rain gauge data, or when you get flow monitor data from a particular location, by looking at the plot of the data and by looking at the time series data, one should be able to ascertain the quality of the data as well. For example, if there are data gaps or if there are sudden spikes, which is not reasonable, then we should be able to identify those from the time series data. Also, it is really important to have the skills to deal with these time series data with respect to filling the gaps or extrapolating the data, etc. Other tools that you can use are Power BI, Python, or R. Second desirable skill I would like to speak about is programming. So if you have good skills in programming, be it VBA for my Excel macros, or Python for scripting, or Ruby, that would really give you an extra edge in your career. For example, Ruby is exclusively used by Innovice Software, by Infoworks ICM. So if you want to do any automation of the process, it is essential to know Ruby. Similarly, Python would help you in data processing, as well as in data processing, be it time series data or spatial data. So that is one of the essential skills. The desirable skill. Third desirable skill is advanced GIS. So if you can develop the skill set of using programming in tandem with GIS, that is, if you can develop Python scripts or any other forms of scripts, or QGIS and or ArcGIS models, that would really be helpful in the due course of the career. And all these desirable skills would really make you stand apart from the crowd when you are trying to get an entry into the industry. Moving on to the career pathways, I have arranged the career pathways under 4 different heads. The first one being hydraulic modeler. Now, under hydraulic modeler, I have listed several profiles. Please bear in mind that these are not mutually exclusive. For example, it does not mean that someone who is working on a river or reservoir modeling would exclusively be doing that during the course of the career. Oftentimes, these different profiles, they interact with each other. For example, in a particular catchment, you would have a coastal component, there would be a groundwater component, there would be a stormwater and wastewater network component, there would be a river as well. So all of these components would interact with each other, and all these profiles, at least, if not all, at least more than 2 of these profiles would be essential and would be something that hydraulic modeler would be working during the span of his or her career. So the first one is river or reservoir modeler, which involves the softwares which solve the shallow water equation. Examples are two-flow, flood modeler, J-flow, JBA J-flow, Bentley open flows flood, etc. Now, this type of studies would mostly be flood impact assessment, flood preparation of flood risk maps, etc. And there would also be instances where you do the optioneering to develop solutions to the flooding problems in terms of flood defenses or in terms of diverting the flow, etc. Second profile is wastewater network modeler. Now, in terms of the quantity of work, wastewater network modeler is a really prominent role, because there is a huge quantity of work that is associated with wastewater network modeling. Because there, so if you consider UK or Australia or New Zealand or other different developed countries, there are water companies that take care of the water supply and wastewater drainage systems. So these companies would be either government or private companies, and they undertake a huge amount of investment into developing these wastewater networks and in maintaining this. So based on that, there is a huge quantity of work and there is a huge number of job opportunities in this particular field. Also, this is, I would say, a really matured area in terms of having the specification. So it has been developing over the years, and there is really good specifications available for wastewater network modeling. The type of work would be, in fact, this is similar to stormwater network modeler roles as well, where you would be modeling the storm drainages. Oftentimes both of these occur in combination. So the type of studies would be, if I'm pointing out examples, it would be development impact assessment. So if there is a development, infrastructure development coming up at a particular location, it is required that the stormwater and the wastewater drainage structure for that particular region be planned along with the infrastructure plan. So that would form one of the type of studies. Then again, there would be optioneering, which is developing of solutions, possible solutions for overcoming flooding issues. There would also be water quality studies, and the softwares used are InfoWorks ICM, Bentley Open Flows, and for storm network modeling, we can use these softwares or two-flow as well. The third profile I would like to discuss is coastal modeling. Now, in terms of the volume of work, if it is sort of a niche area, there is not as much work, quantity of work if you compare with wastewater network modeling or river modeling. But this is also a really promising field, and in fact, an interesting field, because every project is different from one another and there is more of a research route for each of the projects. Now, the type of projects would involve studies about shore protection or shore changes in shore morphology. There would also be studies related to the construction and maintenance of navigation channels, water quality, etc. The software used are Mike by DHI, Aquavio, SMS, etc. Now, clean water modeler is a different role where you model water supply networks. So essentially, that would help us understand the network, plan the maintenance, etc. For example, if you want to understand what happens if you close a particular valve, which areas would be affected, the water companies, they would rely on the models of a particular city. InfoWorks WS, Bentley OpenFlows Water Gems are the two prominent softwares that are used in this field. Now, groundwater modeling is another profile coming under hydraulic modeling head, where you model pollutant transport, water quality studies, etc. Now, this is also, in terms of the quantity of work, this is also a niche area, but oftentimes what happens is the catchment is studied as a whole. In fact, that is an emerging trend where rather than studying different components separately, the catchment is being studied as a single entity as an integrated catchment model. So with that would involve all the type of flows like groundwater flows and groundwater flows, surface water flows, storm and wastewater network flows, etc. Or and coastal flows, coastal modeling also, if that is applicable, if it is a coastal region. So everything interacts with each other, and the model is as such becomes an integrated catchment model. Second heading of career pathways is hydraulic designer, under which there are different profiles, one of which is drainage design. So a drainage designer would essentially be involved in the design of longitudinal and cross drainage works for roads and railways. They would also be involved in the design of culverts, bridge openings, etc., and other different hydraulic structures such as weirs, spillways, etc. Now, the softwares used are Innovice Micro Drainage and Culvert Master. 12D is used mostly, almost exclusively for Australia, but for the rest of the world, Innovice Micro Drainage or Culvert Master is widely used. Now, stormwater or wastewater network design is another profile under hydraulic designer roles, where drainage for new infrastructure developments is designed, as well as treatment plans for treatment of the wastewater networks are designed. Bentley OpenFlow StormCAD is one software that can be used for design. Sometimes Innovice ICM is also used, which is essentially a modeling system software, but sometimes it is used in tandem for during the design phase as well. The third profile under hydraulic designer head is the design of water supply systems. Now, drinking water supply systems and treatment plants associated with it uh, are to be for the design of drinking water supply systems and the treatment plants associated, as well as for the maintenance of those assets. Uh, 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 the contribution of a hydraulic designer is really important. The software used is Bentley OpenFlow's Water Gems. It is almost most widely used software, but there are other utilities as well, which are also used. In fact, for water supply, there are few free and open source softwares that are available, freely available softwares as well, that can be explored. Third career pathways is something slightly different from what we have discussed so far, as in it caters to a different industry altogether, and the type of modeling undertaken is heavily relies on stochastic modeling. So this is catastrophe modeling, or CAT modeling, as often abbreviated. It mainly caters to insurance industry or reinsurance companies or government bodies. Now, these models, they often cover a really large area, sometimes a whole state or a country, or even there are models which cover whole of South Asia as well. So it is, in terms of the geographic scale, it covers a huge area, and the outputs from the modeling is used to inform risk management strategies for different companies, mostly insurance or reinsurance companies, and sometimes government bodies as well. The fourth the fourth career pathway is that of hydrologist or hydrogeologist. I have combined them, just although the roles are differ significantly, although the roles differ, I have combined them for the sake of simplicity. Now, hydrologist, the role of hydrologist is something that is really important, as in the hydrologist is the person from whom the hydraulic modeler or the designer takes data from. So essentially, the calculations that are done by the hydrologist in terms of the design rainfalls or any other hydraulic calculations are fed into the modeling softwares and design softwares. So essentially, if the hydrology goes wrong, the rest of the project goes wrong. So this oftentimes in most of the companies, there would be a separate group of professionals who are working on hydrology, but sometimes depending upon the complexity of the project, if it is a very small project or if it's not a very detailed project, sometimes the hydraulic modelers are themselves are involved in the development of hydrology as well, hydrology calculations as well. Now that we have come to a close regarding the different career opportunities, I would like to discuss the some of the emerging trends. Now, these essentially are not very recent trends. Some of these have been in existence for over a decade, and but they are gaining a lot of prominence these days in the past few years. In fact, with the increased concern about climate change, uh, many of the trends which is listed here, they are given increased importance in these days. So the first one is the use of surrogate models. Now, surrogate models actually replace the physical equations with a machine learning algorithm. So for example, if you have worked on hydraulic models before, the simulation time becomes a constraint when you are working on large scale models at a very fine spatial and temporal resolutions, or if you have multiple simulations to be taken to be run. Now, in terms of the timeline, there are simulations that would run over multiple days or multiple weeks even. So which becomes a constraint in terms of project delivery. So that is where surrogate models comes in. In the traditional method of modeling, all the softwares which we have discussed before, all of them solve different equations. So different equations of flow. Now, that is a computationally intensive task. In what surrogate models do is they replace that physical engine, the calculation engine, with a machine learning algorithm, so that the simulations become much faster. If to give an example of the scale, simulation of coastal models that would take 2 to 3 weeks can be completed in one day, one single day, if we are able to use the proper surrogate models. Now, this is a huge achievement, and this is something that is being developed, that is under development, and in fact, it is also being used in some of the projects in the past 3-4 years or so. Second emerging trend is with respect to the climate change and climate change mitigation and adaptation strategies. With the increased concern about climate change, there is an increased pressure from different stakeholders uh, to uh, to make the uh, future proposals, future designs adapting to climate change. So that is an important emerging trend with respect to the quantification of the effect of climate change in the future. Now, sustainable urban drainage systems has been in existence for so many years now, but it is becoming prominent these days, where there is an increased pressure to reduce hard engineering measures and to while trying to overcome floods, or while trying to adapt to the flooding, instead of resorting to hard engineering options, there is an increased use of sustainable urban drainage systems. Now, these systems, they work along with the nature. They do not contradict the natural flow of water, or uh, the natural flow of water. In fact, they work in tandem with the nature, so that there is minimal impact of these developments to the nature. Now, there is an increased there is an increased trend into using reusing and recycling of water, and there are several technologies that are being developed constantly in this field as drinking water becomes a very scarce resource. uh, Intelligent network technologies is something that is being gaining wide acceptance in pipe network systems, where the metering and detection of leakage, etc., are being done using uh, new technologies such as IoT, by implementing new technologies such as IoT. The last one is wastewater surveillance, which is a relatively new topic, and it has gained popularity after the COVID-19 outbreak, where there were proposals to examine the wastewater that is arriving at the treatment plants to understand the presence of COVID-19 in a particular region. So that has further developed uh, into different proposals, where the wastewater, the monitoring and experimentation, the monitoring of wastewater at different locations catering to different parts of the cities can be used as a treasure trove of information. So looking at the data, it looking at the components that is present in the wastewater, it is possible to make a judgment about the different diseases that is prevalent in a particular part of a city, or even for law enforcement, it becomes useful, where they can detect illegal drugs, presence of illegal drugs, etc. So this is something that is gaining popularity, but there are also privacy concerns associated with it. Now moving on to the chartership opportunities. So I have listed a few chartership organizations, mainly two organizations with which one can become chartered. Now, uh, the first one is SIVM, which is Chartered Institute of Water and Environment Management. They have different levels of charterships, from graduate level to chartered and fellow, etc. Fellow level. This is more useful if you are trying to pursue a career in hydraulic modeler or environment or such related fields. And depending upon your requirement, there are multiple specialities available as well. So there is chartered water and environment manager, or chartered environmentalist, depending upon the specialization that you require. And it is also possible to take more than one specialization as well. The second institute is ICE, which is Institute of Civil Engineers, and this would be more useful if you are going to a design profile, if your job is more oriented towards design, and the qualification is more generic, as in it is not specifically related to water resources or specifically related to water, but it is more generic across different horizons of civil engineering. Apart from these, there are also other local organizations with which one can gain membership, or one can gain membership. There is that is more specific to the region where you are working. So there is Institute of Engineers Australia, there is Professional Engineer certification in US, and in India we have the Institute of Engineers. So all these bodies, they provide certifications or memberships which qualifies you to work in that particular geography. Uh, with respect to the chartership, there is going to be a financial component to it. So once you start working with a particular organizations, if they can sponsor that as a chartership, that is well and good, but otherwise there is going to be a financial component involved as well. Moving to the end of the presentation, I have listed a few useful resources. So the first one is Australian Water School, which is a really useful resource to understand the to understand right from the basics of a particular subject all through to the recent development in that subject. So if you are looking to learn about river modeling, you would find webinars and resources that deals with the basics of river modeling as well as with the recent trends. So this is one really useful website. They often conduct they conduct frequent webinar series on different topics, and all of the previous webinars are also available in their YouTube channel. So that is a really good source of free, and it is free as well. The second source is Cyber website, where you can find guidelines and specifications with respect to a lot of fields, be it wastewater network modeling or be it river modeling. And these are mostly specific to UK, but they are also applicable elsewhere. There is also a YouTube channel where they host interviews and career stories, which would help you understand more about how the career looks like in particular fields, in certain fields. Third one, to develop your skill in QGIS or GIS in general, QGIStutorials.com is a really good resource. Uh, Although it is not specifically oriented towards water resources, it would provide you an overall understanding. And in fact, there are also advanced level tools and tutorials available in the website. Sustainable drainage, like I said in the previous slide, is something that is gaining prominence and there are a special group of professionals who exclusively work on sustainable drainage design. So susdrain.org is one website where you can get a really good overview of what sustainable drainage stands for, what are the different tools available, what are the different ways of representing them, and uh, different components of sustainable drainage. So this would help you understand. This is one of the desirable skills to have uh, that would really help you stand out if you are attending an interview or if you are participating in a recruitment process. Now, the fifth one is also a really useful website, Wiki2Flow, which provides a very streamlined step-by-step guidance to the use of 2Flow software. Now, 2Flow has a free version with certain limitations, but if one can really learn about the river modeling and surface water drainage modeling using 2Flow using this particular website. The extra added advantage is that uh, the processes explained in the tutorial involves extensive use of GIS, be it QGIS or MapInfo. So as one goes through the tutorial, as one follows the tutorial, she or he automatically develops the skills in GIS as well. The sixth useful resource is Flood Modeler website, Flood Modeler YouTube channel, where different aspects of the Flood Modeler software is explained in different webinars. The Innovize website also has several resources that would help you get acquainted with the particular software. JBA Risk is a resource which you can use to inform yourself about the recent developments. So the website hosts a bunch of paid and a few free resources as well. Whenever there is a catastrophic event in any part of the world, JBA conducts their own studies on that particular event and comes out with a report. So it is a very much updated repository of information, I would say. So that is something that you would really help us to keep updated about different developments in the field of water resources. This brings us to the end of the presentation. I am really thankful for inviting me here. I hope I have been able to convey uh, uh, an overview of, I have been able to give you an overview of different career prospects and different skills. And I really hope this has been useful. And my contact details are given here. You may get in touch in the future if you have any queries. And now, if we have time for discussion, I would be happy to answer questions.
Thank you, Jivas, for such an insightful session. You have covered the various relevant aspects required to build a career in hydraulics and hydrology, the skill set required, certifications available, and the job opportunities with companies both in India and abroad, and the type of projects and the role that a water expert can play as well. So now I think I would, before we open the platform for queries, I would like to invite Dr. Ranjana to have an introduction, to have few words. Actually. Yeah.
Yes, thank you very much, Shirley, and thank you very much, Javas, for such a wonderful presentation. In fact, the way you have categorized that one can be a hydraulic modeler, one can be a hydraulic designer, and one can do catastrophe modeling, and how the hydrologist and hydrogeologist's role, everything plays a role, and there is an interconnectedness. So one cannot do without the other. And this is something very important to understand for the audience as well, that knowing just hydraulics or hydrology is, of course, it cannot be in silos, especially when one is doing a master's course. One has to learn both the hydraulics and the hydrology. While you made a very important statement on, hydraulics is the same everywhere because that is artificial flow, the way we look at it. But hydrology is natural, the way water flows naturally in different topographies. People take quite a few years to understand that, if I may make that kind of a statement. So literally your discussion, the way you presented it, was an eye-opener for me also, because I am not a modeler, but that there are so many modeling opportunities is something that I personally did not know, and I'm sure that the audience has benefited from such a wide range that you covered. So if you can just tell us a little bit about what is the basics of hydrology that that somebody should work on as a student, and the basics of hydraulics that they should know, because GIS is something that is taught across the courses, as you rightly said, but these two, can somebody pick up the hydraulics while suppose somebody has not paid too much attention to the subject while studying it in the university, can they pick it up on the go? Similarly for the hydrology or the groundwater. What are your thoughts on that? If you could let us know, Javas.
Sure. Okay. So regarding hydraulics, well, if you are working on projects involving shallow water flow, that is, or open channel hydraulics, then so if you are doing a run-of-the-mill task, it would not matter much if you don't know the hydraulics. But where it matters is when you are looking at troubleshooting a model, or when you are trying to understand the model in depth. So that is where your understanding of open channel hydraulics comes into picture. The academic background that we received during the master's course, I am sure the programs are more or less similar in terms of the core courses. So that would really be sufficient. And if one has not really paid attention, in fact, it is it is something that someone can revisit once they start working and to understand. So once we start working, if you want to understand the projects in depth, if you want to troubleshoot the models, then you would automatically have to go to the basics. So you would have to revisit your theory. You would have to go back to the theory and read the books once again, and that would really help you understand, improve your understanding of the subject as well. And in terms of hydrology, the routing techniques would be sufficient, and one of the major things about hydrology is for the commercial projects, the hydrology is based on the specification. So the different organizations, be it environmental agency in UK or the other government agencies in different countries, they have come up with the specifications uh, for the particular regions. So for most of, I would say almost 90% of the projects, be it it is a requirement that we follow the specifications. Only in very few cases where we have a bespoke project where we are exploring something new, we would have to have a research oriented approach towards the hydrology. But in most of the cases, it is driven by the specifications that exist in the particular region, because at the end of the day, these projects go in for approvals from the government agencies, so mostly the government agencies. So it is essential that we follow the specifications.
Yes, thank you. So essentially one has to read the manual word by word for whichever country, and if one understands the manual, that is good enough. I specially asked you this question, Javas, because many of our students, we are an interdisciplinary course, so
Okay.
we allow students from different background, not specifically civil engineering or environmental engineering. So they come from mechanical engineering background, electronics, computers, and the view that we have taken is that when it comes to climate change, everybody has a contribution to make
Yes.
in today's world. So that's the reason we have done it that way.
Okay.
So yeah, so thank you very much, Javas. And now
Thank you.
the floor is open for questions.
Hello, I'm audible.
Yes. Hi, Sahil.
Hi, I'm Sahil. I'm from MTech Water Resource in Terraces. And my question is, you mentioned about the CAT modeling. Like it is different than conventional modeling in terms of extent. So are there any other factors like the parameters and something which differ in the conventional CAT modeling?
Yes, there definitely is. So they are mostly stochastic models. So there is a lot of statistics involved. To be honest, I haven't worked in that field, but that is something it is so if you consider in terms of a career perspective, that is largely different from what you would be doing in an engineering firm. The objectives are different, the methods are also different. uh, in an engineering firm which I am working in, you would be dealing with softwares that solve the physical equations of flow. But the other one, it's a very broad scale model, I would say, and the objective is not to have very fine detail, but rather to have a broad overview of a risk. Uh, so yeah, in terms of that, it is very different.
Yeah, got it. Thanks.
Thank you.
Anyone else wants to ask a question, especially on the GIS background or any other background? You're most welcome to go ahead and ask him. He has quite a few years of experience and he can clarify your doubts.
Hi, Javas. Am I audible?
Yes, I can hear you.
Yes, it was a wonderful session on career
Thank you.
opportunities. So I'm a master's. I have done master's in water resource engineering, and I'm a
Okay.
faculty in engineering college.
Okay.
So are there any career opportunities for changing from academics to industry? Like we have a little known knowledge on GIS. So if we develop all the requirements needed by the company specifications, so are there any chances of changing?
Yes, there are actually, and there are people who have come from academic background who have transitioned into a professional career from the academic background. what I would say is one of the blockers that you might face is that you would have to start have to take a step backwards and then start from there. So there would be that taking that step backwards and then starting from there. That would be the only blockage I can think of. And if you are okay with that, there are definitely opportunities, and there are people who have done that.
Thank you, Javas. Thank you.
And there are people who have done the other way as well, people who have gone from working in the professionals engineering sector for a few years and then move to the academic sector. It depends on what you would like to do for yourself. The career path you want to choose, it depends on that.
Good afternoon. Can I have a word on career placements?
Yeah, sure. Good afternoon.
Good afternoon. I am Professor Seshadri, and I've been on this water initiatives and environmental initiatives for quite some time.
Okay.
And now there is a wave, total wave on sustainability and sustainability responsibilities for various executives. That is one thing. Second one is this SDG has always been there. No compliance to SDGs at local and at higher level. And now another one is ESG.
Yes.
If people can invest at least 6 months to 1 year studies on ESG, proper studies, while they are working, a lot of good things will come up, because every company now is wanting juniors, seniors, and really high level people on ESG and ESG reporting. I just want to add this and enlarge this as a good something like a notification to all graduates and other officials who are wanting to go for placements and other things. Thank you.
Yes.
Thank you very much.
Thank you.
So we have time for one more question if there is somebody who would like to ask, and then we shall close the session. So anyone else who is interested may please ask the question. So yes.
Yes.
Someone
Hello, good
want-
morning.
Yeah. Yes, Yukti, please go ahead.
Yes, hello, sir. Thanks
Hello.
for this wonderful session. So
Thank you.
I would actually like to know, as in I have a research background, like I have done
Okay.
researches, and for a person to like, I am an MTech water resource, so I know the basics of every little step that is being taught. But I just wanted to know whether one with a totally different background if like to just enter into the industry. So what are the basic requirements that I need to fulfill? What is the first step that I have to take to actually go into this hydraulic modeling thing?
Well, if it is hydraulic modeling in specific that you are looking for, what I would suggest is one of the resources which I had mentioned, the wiki.2flow.com. So that would be a really good start point. So the major thing is that it is freely available. Second thing, it is used in the industry widely. So if you complete the tutorial, you would have a good grasp of what hydraulic modeling does in the from a industry perspective, from a commercial perspective. So I think that would be a really good start point. And in fact, there are quite a few openings at this point. It is sort of a period of boom in terms of job opportunities, and I think if you have, if you can develop this right skills, obviously you would have the skills from your masters, and along with this added in knowledge, I think it would definitely be possible to move from a research career to an industrial career.
Okay, thank you, sir.
Thank you.
Thanks a lot.
So thank you everyone, and thank you Jawaz very, very much for answering the question so clearly. I'm sure the doubts are all clarified. Over to you, Shirley.
Okay, I think I don't, I don't have much words to say, but I'm so happy, to say that in such a short, notice, Javas was ready to give such a wonderful presentation, and so thank you so much, Javas, for
thank you very much for the
such a
opportunity.
prompt response and support. Yeah, and also I would like to thank everyone who are present in this webinar, and thank you all once again. Yeah. Have a nice day.
Yes. So